Now that we know how to use trig to solve for missing side lengths of a right triangle or a missing angle of a right triangle, we're going to apply that to real world type situations. Okay, I got two problems up here. Each one comes with a new vocab, and we're going to use that to solve. So let's dive in. Okay, so over here, you're standing 50 meters from a hot air balloon that is preparing to take off. The angle of elevation to the top of the balloon is 28 degrees. Find the height of the balloon. So to start out, what I'm going to do is I'm going to give myself a little bit of a diagram so I know what I'm looking at. So real cheesy as it is, I'm standing, 50 meters from a hot air balloon that is preparing to take off. Okay? I am looking, or we're creating that angle of elevation. So that is my key word here, angle of elevation. Angle of elevation, we're going to start horizontal and we're going to look up. It creates this angle, which here is 28 degrees, and I want to know the height of this balloon. So what we've just done is we've created this right triangle. Here's my 90 degrees. Here's the angle of reference. We know the base of the triangle, and we're trying to find the height. Or in trig terms, based off of my angle, I know the opposite and adjacent side. So this is dealing with tangent. So if I set this up, I have the tangent of 28 degrees equals 50 over x. So now I've just set up an equation like we've done before. Now I just have to isolate the x. So I'm going to multiply both sides by x. So x times the tangent of 28 equals 50. And now I'm going to divide by the tangent of 28. So x is equal to 50 divided by the tangent of 28. But we're not going to leave it there. We're going to actually figure that out in feet. So we're going to use a calculator. Making sure we're in degrees, I'm going to type in 50 divided by the tangent of 28. Did I do something different? Yeah, I did. Why don't you guys tell me when I'm wrong? You got to tell me when I'm wrong. How do we set up tangent? Tangent isn't 50 over x. That's embarrassing. I make mistakes on a video. Oh, heavens. So this is my x here. Tangent is opposite over adjacent. So all I got to do here is multiply both sides by 50. So x equals 50 times the tangent of 28. So 50 times tangent of 28. The height of our balloon is 26.6 meters. Okay, so be careful with your setup. Tangent, based off my angle, is opposite over adjacent, so x over 50. All right, whoo, my bad. Second problem that we're looking at here says from a 200-foot observation tower on the beach, a man sights a whale. Missing an S there, but that's okay. If the whale is 1,600 feet from shore, what is the angle of depression from the tower to the whale? So again, I'm going to get myself a little visual. So I've got my observation tower. Whee, super cute, I know. And out here swimming, there's a whale. Okay, so my tower here is 200 feet tall, and the whale is 1,600 feet from shore, and our buzzword here is angle of depression. So an angle of depression, we're going to start out at horizontal, and we're going to look down. So from my tower, here's horizontal. I look down at the whale. This is 7 degrees. The trick here is my right triangle My 7 degrees is on the outside of that triangle. There are two ways to take care of that problem. When we're dealing with angle of depression, an angle of depression is actually equal to your angle of elevation. So we can drop that 7 degrees down here to the whale, creating the angle of elevation, looking up to the tower. We could also come in and use the complementary angle. Here we're at 90 degrees, so if this is 7 degrees, this becomes 83. Either way, we'll get the same solution. Doesn't matter what angle we're using as long as they're in the proper place. So we'll just go ahead and drop our 7 down here to angle of elevation. Wait, I don't know where this came from. Our angle of depression is our unknown. That was very strange. I apologize. So it's unknown. So because it's unknown, we're going to drop down here, and that's going to be our angle of reference. Based off of our angle that's unknown here, x, we know opposite and adjacent, so again, this is going to be a tangent problem. So this is the tangent of x equals 200 over 1600. And we're going to solve for x, so we're going to go ahead and use our tangent inverse of the 200 over 1,600. And this is where we're going to plug it into our calculator. So I've got my tangent inverse, 200 divided by 1,600, and I'm going to get x is about 7.1 degrees. So originally this problem, we knew the angle, so that's why I knew it was 7, but there we go. Okay? So it's just building that triangle, setting it up, and using our trig to solve. Good luck. Oh, I've been told to say this. Please like and subscribe.